I hope you're all well, and welcome to the first video of the GCSE chemistry series, and I'm going to be using the Edexcel IGCSE syllabus. So we are going to be going through topic 1 first, which is principles of chemistry, and I'm going to break this topic or chapter into 3 lessons. So each lesson we're going to be going through a few of the specification points, and let's see how many we can go through this lesson. So starting off from 1.1, we have to understand that the 3 states of matter in terms of the arrangement, movement and energy of the particles. So the 3 states of matter, folks, please be taking notes, are solid, liquid and gas. In gas, particles have the most energy as the particles are the most spread apart with a random arrangement. In liquid, particles have more energy than those in solid, but less than those in a gas, and the particles are closer together, but they have a random arrangement. Solid has least energy. The particles are not moving, they're just vibrating, and they are arranged in a fixed position and are very closely together. So moving on to 1.2, we have to understand the interconversions between the 3 states of matter in terms of the names of the interconversions, how they are achieved, the changes in arrangement, movement and energy of the particles. So the physical changes involved the forces between the particles of the substances instead of these interconversions being chemical changes. So it's the forces between the particles. So melting and freezing take place at the melting point. So from solid to liquid, it's melting. From liquid to solid, it's freezing. Boiling and condensing takes place at the boiling point. Liquid to gas is boiling, and gas to liquid is condensing. So when you go from liquid to to gas, the particles gain more kinetic energy because they're more spread apart. They get more spread apart, and they move around more and become more randomly arranged and further apart. But when you go from a gas to a liquid, the particles lose energy because they become more regularly arranged and close together, and they move less. So moving on to 1.3, we have to understand how the results of experiments involving the dilution of colored solutions and diffusion of gases can be explained. So we need to know that diffusion is the movement of particles, a net movement to be precise, from an area of a higher concentration to an area of a low concentration. If you study biology, you will know this. For this to work, the particles must be able to move. So as a result, therefore, diffusion does not happen in solids, since the particles cannot move from place to place, they only vibrate. Solid particles only vibrate in a fixed position. Therefore, colored solutions are diluted by adding water, which is liquid, not solid, because the particles of the color, they fuse to the air of low concentration. Yes, so the particles go from a high concentration in the color solution to where there's not much of the particles because there's not much of the colored solution. It mixes with the water molecules, which causes dilution, a process, to occur. So 1.4, we have to understand what is meant by the term solvent, solute, solution, and saturated solution. Okay. So a solvent is a liquid in which a solute dissolves. So that might be lime water or whatever. So it's something that a solute, which is a substance that dissolves in a liquid to form solution. Something that's a solution dissolvent. A solution is a mixture formed when a solute has dissolved in a solvent, and a saturated solution is a solution in which no more we've reached the maximum, which no more solvent can be dissolved. 1.5. We need to know what is meant by the term solubility in the units gram per 100 grams of solvent. So solubility is shown as the grams of a solute that will dissolve in 100 grams of water. In other words, solubility is a phrase of describing the amount of solute that will dissolve in 100 grams of water. So 1.6, understand how to plot and interpret solubility graphs. So generally, solubility of solids increases when temperature increases. Solubility of gases increases when pressure increases. So when pressure and temperature increases, solubility of solids and gas both increases. Any mass below the line for a solute at a specific temperature would mean the solution was unsaturated. Any mass above the line for a solute at a specific temperature would mean the solution was super saturated and unstable, which means that no more solvent can be dissolved in it. Well, this brings us to the end of part 1. Please move on to part 2 now. Thank you very much for joining us, folks, and I hope to see you in the next one. Thank you.